dispersal areas. The number of unexploded bombs to be cleared and the number of craters to be repaired will be factors, and even the spacing between craters can be critical. All these factors must be understood and presented by the ADR cell so that the sapper squadron commander is able to accurately and completely brief the station commander on the options available.
Is your best bet.
Agreed on that. Now, wait a minute. What about access?
Okay, sir. First of all, the western end doesn't look too bad in the actual dispersal themselves, sir.
Once the decision is made, a quick radio briefing tells the bomb disposal teams and troop commanders exactly what is required, and they are dispatched to their tasks.
Mike, Hotel 1.
Roger.
On training exercises, it's only possible to make 1 or 2 craters on a taxiway, access strip or dispersal area so that routine flying operations are not disrupted. But before we see the troop tasked with the repair of these 2 craters in action, let's look more closely at the crater itself. Most conventional bombs dropped on an airfield pavement will leave a crater looking like this. Around the edges, great slabs of heaved concrete protrude above the normal pavement level. Ejected material surrounds the crater lip just where it fell. In the bottom of the crater is the ejected material which fell back into the crater hole, and below that, a layer of loosened soil known as the ruptured zone. The clean bowl technique, the conventional British method of repairing craters, is to remove the ejector and heave from the site, and then to excavate first the fallback, and then sufficient of the ruptured zone to give a smooth profile to the crater. The hole is then filled with a single-sized nominal 50mm coarse aggregate to within 500mm of the top. 2 capping layers, each of 250mm of graded aggregate, are laid and compacted separately. The surface is screeded flush with the surrounding pavement and the area swept clean before bolting a bomb damage repair mat over the top to complete the repair. Another method which will complement the so-called clean bowl repair is called dynamic compaction. Instead of clearing away the ejected material fallback and part of the ruptured zone, ejector is all dozed back into the crater and then compacted by dropping a heavy weight from a considerable height using a special crane. Once the fill is compacted, the resultant saucer shape is filled with fine aggregate, screeded, and covered with a mat as before. But the troop we're going to see at work will be using the clean bowl technique to repair the craters at the east end of the MOS. At the crater site, the RAF bomb disposal team have already arrived and started work. A number of bomblets with delayed action fuses or anti-handling devices lie amidst the rubble. They were dropped by the enemy to hamper progress in repairing the craters. Further up the MOS lies a 250-kilogram unexploded bomb. The team will clear the bomblets first in order to get the sapper crater repair troop to work, and will then move on to deal with the UXB. There are various methods of clearing these bomblets. These men are using small-shaped charges to penetrate the bomblets, thereby detonating or neutralizing them. Once the crater is clear, the sapper troop commander arrives and is briefed on the situation. As the bomb disposal team move on to deal with the UXB, the crater repair troop is called forward from their hide in nearby woods. And the heavy plant breaks cover en route for the task. One heavy-wheeled tractor and the grader arrive on site, and together clear a path through the debris to the crater edges. The troop will practice a technique of repairing two craters simultaneously to make the most effective use of their plant resources. Meanwhile, the other heavy-wheeled tractor collects a repair mat from the designated stockpile. There are several such stockpiles scattered around the airfield. The mat is loaded onto the special trailer and once towed to the repair site is left on the side and out of the way. At the first crater, the heavy-wheeled tractor is joined by both medium-wheeled tractors, which are worked in concert to scrape together heaps of spoil for the heavy tractor to push off the MOS. If there was water in the craters, then the sludge pump would be brought in at this stage to remove it. The plant sergeant has now called forward the mechanical hammer to break up unmanageable slabs of heaved concrete and to clean up flaking crater edges. The next piece of plant at the crater's edge is the heavy-wheeled excavator. Some heave and ejector have already been removed by the tractors, and this beast is to attack the remaining heave, the fallback and the ruptured zone excavations. All excavated material is dumped at the side and is cleared away by the ever-attentive medium-wheeled tractors. The mechanical concrete hammer has completed the task at Crater 1 and moves to Crater 2. The second excavator has now arrived. Had Crater 1 been very large, it would have helped with the excavation there. But here, the first machine is coping well, so the second has moved directly to Crater 2. Crater 1 is now ready for fill material, and no time is being wasted. These tippers were filled beforehand in readiness and are fitted with extension sides to increase their carrying capacity. At the stockpile, the tractor operator is in radio contact with the plant sergeant at the crater site. He therefore knows how progress is going and when to change to loading the fine aggregate for the capping layers. Back in Crater 1, a medium-wheeled tractor is leveling the tipped aggregate, moving on to Crater 2 to level the fill going in there. Crater 1 has been filled to within 500 millimeters of the pavement surface with coarse aggregate, and the first layer of fine aggregate is now being placed. A medium-wheeled tractor levels this fill, while the other has collected the towed vibrating roller from the stores area. The vibration is only operated while the roller is in the crater to avoid damaging the surrounding concrete. The second layer of fine aggregate is placed at Crater 1. The skill and judgment of the plant sergeant are tested here as he attempts to gauge the amount of aggregate tipped as accurately as possible. The second layer is compacted and Crater 1 is now ready for screeding. This specially designed screed beam was brought to the site on the mat trailer before the first mat was collected. It's now harnessed to a heavy-wheeled tractor and dragged over the repaired crater, thereby skimming off any surplus fill material. This is done twice from side to side in case any stone spills over the top of the beam and to achieve the best possible profile to match the surrounding pavement. As the screed beam is taken off to the second crater, the other heavy-wheeled tractor is back from loading aggregate at the stockpile. Having lifted the mat from the trailer by crater 1 and under direction of the plant sergeant, a team brings it forward and lays it down at the crater edge on wooden chocks to enable the strops to be removed. Final sweeping round the crater edge must be done by hand, but a motorized sweeper has been on the site, sweeping up debris once the medium-wheeled tractors have finished their clearance, and supporting the grader, which has been clearing debris from the MOS between the craters. All available hands are now called for to unroll the mat, for mechanical assistance would damage it. A big push soon sends it clattering over the repaired crater. Special strops connect one end of the mat to the tractor, which then pulls the whole mat a few inches to take up all the slack between the planks. As soon as the mat is down, the 6 kVA generator trailer is towed in and cables run out to power 4 hammer drills. Working to a practice routine, the sappers soon have 56 holes drilled through the countersunk holes in the fairings and into the pavement beneath. As each hole is drilled, so an expanding shield roll bolt is dropped in and tightened.